Units can help us actually in performing our calculations correctly. Scientists often use the technique of dimensional analysis to double check whether or not the results of a calculation came out correctly. For example, if you were to calculate or be asked to calculate a velocity or a speed and your answer came out in anything other than units of length divided by time, or an acceleration, it came out in some units other than length divided by time squared, you might guess that your answer was incorrect or that you'd made a mistake somewhere along the steps of your calculation. So let me just give an example of trying to use such a technique to double check or to more speedily answer a problem. So if we imagine a ball on the end of a string, which moves with a speed v, we'll come to derive this expression soon enough, but even from the choices given, I can show you that one of the following multiple choice answers would be the unique one that would give you the correct units for acceleration. So if we imagine here now a ball moving on the end, like a tether ball, moving around in a circle with the speed v, you could be asked to differentiate between the following answers. If we inspect each of these separately for what is the units of the expression given, we're looking for something that has units of length divided by time squared, because that's what acceleration is. So this one right here has a length over time because of its velocity. If I multiply by another length, then I have length squared over time, which is not correct. And if this one is length squared over time squared, and I multiply by yet another length, I have length cubed over time squared. That's not correct. This is length divided by length over time, which just becomes time in the end. The lengths will cancel out. Answer D actually is correct. It looks like it's length squared over time squared, but then I divide out one of the lengths. So it becomes length over time squared. Answer E becomes length times length squared over time squared. So actually that's the same as answer B, and answer F is length over time divided by time, length squared, so that becomes 1 over length over time, and that's not correct. So the correct answer here is this one, because in this case only do we have length squared over time squared, and we're divided by 1 over length. So this becomes length over time squared, which is required for any answer about acceleration. We can take this further and consider other kinds of problems. So we can imagine a car moving along. At some speed, and ask how much time does it take for this car to cover a distance d. Our answers might span a couple of possible choices. Let's just look through them together. So we're looking for a time, because we're asking how long would this process take. Answer 1 would be a length over a time. Multiply that time, so by a length, that would be a length squared over time. That's not correct. This would be 1 over that, so that would be a time over a length squared. Again, not correct. Answer C would be a length over a time divided by a length, so that would be 1 over a time. That's close, but it has the inverse of what we want. Answer D appears to be correct. It's a length divided by a length over a time. So it just becomes a time. And here's a length squared over time squared divided by 1 length. It's length over time squared. That looks more like an acceleration. And this is a length squared divided by a length over time. So that becomes a length over a time to time, excuse me. So in fact, the only correct answer here is this one. And I will point out that actually this particular answer D has a particularly intuitive sense to it. Because if you look about what is this delta time or this time interval, it intuitively should take less time for the car to cover a certain distance if the speed is quite larger. So that's a very reasonable thing. We know that we can get to Dallas more quickly if we're traveling at 100 miles an hour than 60 miles an hour. And if v gets larger and larger in this expression, then 1 over v gets smaller, and this time interval goes to 0 as this velocity speed v goes to infinity. So this is another technique besides dimensional analysis that scientists use very frequently, and that is to look at limiting cases, like the sense of what are the extreme variations of this answer as I take one or other variable and either have it go to 0 or have it go to an infinitely large case. And that's another way of checking whether or not your answer is correct on a problem.